Hello there and welcome to my video on tangent lines and polar curves. So let's get started. Find the equation of the tangent line to the polar curve r equals 3 sine of theta at the point theta equals pi over 6. So the first thing that we need to do is we need to find the slope of the tangent line. That's usually the first thing that we do whenever we need to find an equation of a tangent line, is we want to find the slope. Well, the slope of the tangent line is, as it always is dy dx. It's the derivative of y with respect to x. The problem here is everything is in polar coordinates. Well, let's take a look at our equations in polar curves. So we know that x is equal to r times the cosine of theta, and we know that y is equal to r times the sine of theta. Well, if we assume that r is a function of theta, which it is because r is equal to 3 sine of theta, r is a function of theta. So because r is a function of theta, let's substitute that in for our equation for x. So we have a function of theta, f of theta, times cosine of theta, and y could be rewritten as f of theta times the sine of theta. Now, dy dx, if you go back to our study of parametric equations, can be determined by finding dy d theta and dividing it by dx d theta. So what we have to do is we have to find the derivative of both of these. So dx d theta is the derivative of x with respect to theta. Well, we have the function of theta times the cosine of theta. It's a product. So we're going to have to use the good old product rule. So I hope everybody remembers the product rule from Calc 1. We take the derivative of f of theta, so f prime of theta times cosine of theta, plus f of theta times derivative of cosine, which is going to be sine of theta. And then, of course, this is going to become minus because the derivative of cosine is negative sine, so we'll change that to a minus. Likewise, dy d theta is going to be equal to f prime of theta times the sine of theta plus f of theta times the derivative of the sine, which is the cosine of theta. Okay. So now to find dy dx, we need to take dy d theta and divide it by dx d theta. So let's do that down here. So our slope is dy dx, which is going to be equal to f prime of theta times the sine of theta plus f of theta times the cosine of theta. And that is being divided by this. So that's f prime of theta cosine of theta minus f of theta times the sine of theta. Now, what do we do with all of this? This looks like a great big old mess. Well, now what we need to do is we need to substitute in some values that we know. Going back to our original equation, which is r equals 3 sine of theta. Let me rewrite that down here. We know that r is equal to 3 sine of theta. And so the derivative of this, remember that r is 3 sine of theta. This is f of theta. F of theta is 3 sine of theta. So what we have to do in both of these numerator and in the denominators, we need to find the derivative of that. So f prime of theta is 3 cosine theta. So let's substitute in to our derivative. So the slope is going to be equal to f prime of theta, which is 3 cosine theta, times the sine of theta, plus f of theta, which is 3 sine of theta, times cosine of theta. And then that is being divided by f prime of theta, which is 3 cosine of theta, times cosine of theta, minus f of theta, which is 3 sine of theta, times sine of theta. Well, in the numerator, it looks like we have 6 sine cosine. We have 6 sine of theta, cosine of theta. And in the denominator, we have 3. I can factor a 3 out of here. I'm going to factor a 3 out. And then what I'm left with is cosine squared theta minus sine squared theta. All right, so it doesn't look like we're in any better situation than we were, but we are, because we're going to use some trig identities now. In fact, we're going to use the trig identity that the sine of 2 theta is equal to 2 sine of theta cosine of theta, and that the cosine of 2 theta is equal to the cosine squared theta minus the sine squared theta. Those are 2 trig identities. And we're going to substitute this one in the numerator and this one in the denominator. Now, we have a 6 here. So basically, think instead of a 6, let's think of that as 3 times 2. I can cancel out those 3's, and I'm left with 2 sine theta cosine theta. So I can substitute in for that sine of 2 theta. And in the denominator, I have cosine squared minus sine squared is the cosine of 2 theta. Well, sine divided by cosine is tangent. So we have the tangent of 2 theta. And so we want to evaluate that at pi over 6. So the slope is going to be the tangent of 2 times pi over 6, which is pi over 3, which is radical 3. The tangent of pi over 3, or 60 degrees, is radical 3. So my slope is the square root of 3. That is the first thing I need to find. Now, you could have actually evaluated this and found the same answer way back up here if you didn't want to do all of this trigonometric substitution and with these identities. You could have gone up here and found the cosine of pi over 6, sine of pi over 6 plus 3 sine of pi over 6, cosine of pi. It would have been a lot more work evaluating, but you could have done it at that particular point in time. Okay, the next thing that we want to do, now that we have our slope, is we want to find out what is r, find r when theta is pi over 6. Well, that's not too hard, because we know the relationship is r is 3 times the sine of theta. So r is equal to 3 times the sine of pi over 6. So r is 3/2. Now what we have then is we have a point in polar coordinates. We have our polar coordinate point, r theta, is now 3/2 pi over 6. And we need that because we're going to need to convert into x, y coordinates. Our slope is not going to be in terms of r and theta. It's going to be in terms of x and y. We want a Cartesian function here. So the next thing that we're going to do is to convert our point r theta to xy. And so to do that, we go back to our basic identities. X is equal to r, cosine of theta, and y is equal to r sine of theta. So x is going to be equal to 3/2 times the cosine of pi over 6. And y is going to be equal to 3/2 times the sine of pi over 6. Well, the cosine of pi over 6 is radical 3 over 2. So we have x is 3/2 times the square root of 3 over 2. So x is 3 radical 3 over 4. And y is equal to 3/2 times 1/2. The sine of pi over 6 is 1/2. So y is equal to 3/2. Oh, sorry, 3/4. Whoops, forgot to multiply the denominators. 3/4. So now what we have is we have a point in Cartesian coordinates, which is 3 radical 3 over 4 and 3/4. Finally, the last thing to do is something that you did way back at the beginning of Calc 1, is we want to go to y minus y1 is equal to m times x minus x1. We have everything that we need. We know that our slope is the square root of 3. We know that x sub 1 is 3 radical 3 over 4, and y sub 1 is 3/4. So it's a matter of plugging them in. Y minus 3/4 is equal to the square root of 3 times x minus 3 radical 3 over 4. And simplifying here, radical 3 times x, radical 3 times 3 radical 3. Well, the radical 3 times radical 3 becomes a radical 9, which becomes 3 times 3 is 9/4. And finally, adding 3/4 to the other side, we end up with y is equal to the square root of 3 minus 6/4, or 3/2. And so there is the equation of the tangent line. So what we should have, if I was just to draw a real quick sketch of this, is we have a circle, and we know that that circle is going to be centered something like this. And we have the line pi over 6, which is here. And so at the point at pi over 6 intersects, we're finding the tangent line. And so that's what we have just found. And so now I'm going to go to Desmos, and let's take a quick look where I've graphed all this in Desmos. I've graphed the equation of the line in Desmos, and here we have it. So here in red is the circle, 3 sine of theta. And here is the ray coming out for pi over 6, and you can see pi over 6 intersects the circle exactly where our tangent line does. So it looks like we got this tangent line just perfect, right? And we can zoom in there, we can see that it is tangent. And the equation of the tangent line up here is radical 3x minus 3/2. And so there is a new twist on an old problem, finding the equation of a tangent line, but this time it was given to us in polar coordinates. All right, I hope you enjoyed this video.